go to page 156 and fill in the definitions in your journal for 6.1. Then I want you to scroll down or look down on the page and look at the core concepts. We have this first one for exponential growth functions. You can see the function is going from left to right, going up. It's increasing, okay? And then if you go to the next page, we look at exponential decay functions. The function is going down from left to right, and it is decreasing. And then take a look at your Chapter 6 notes packet. We're going to do example 1, parts A and B. It's asking us to tell whether each function represents growth or decay, and then graph it. So I know that it's going to represent growth whenever the base number is greater than 1. So I have 2 here, so I know that this is going to be growth. And then for part B, I have 1/2. So whenever the base is between 0 and 1, it's going to be decay. And then we want a graph. So I'm going to draw my X and Y axis. And you can pick wherever you want to draw them, in the middle or off to the side. I think I made mine off to the side. And I want to plot just a few points just so that I can make this graph as accurate as possible. So I'm going to make a little XY table, and I'll plug in -1, 0, and 1. Let's try that. So if 2 to the -1 is 1/2, 2 to the 0 is 1, and 2 to the first is 2. So if I plot those points, here's what I get. And I know it's going to be a curve going up. So it will look something like that. You can also look at this in your graphing calculator. And then if we make an XY table over here, I'll do the same points, -1, 0, and 1. 1/2 to the -1 is 2. 1/2 to the 0 is 1. And 1/2 to the first is 1/2. So now I want to plot these points on my graph. And I know the graph is decreasing from left to right. We're going to do the monitoring progress 1 through 4 in class together tomorrow. So take a look at example 2. And we need a special formula from our book here. And that formula is going to be y equals a times 1 plus or minus r to the t power. The plus is when you have exponential growth, and the minus is when you have exponential decay. So looking at this, they already give us the formula. If you read through example 2, they already give us the formula for y equals a times 1 plus or minus r to the t. We need to figure out, is it going to be growth or decay? So 0.85 is less than 1. So that means there must be subtracting in there, and this is going to represent decay. Okay? Because my rate is between or less than 1. And then for part B, if I want to identify the annual percent increase or decrease, we're looking at decrease for the car. And we want to look for something in this form, 1 plus or minus r, that equals 0.85. So we know it's decrease, so it's going to be 1 minus r equals 0.85. Or you could say 0.85 if you prefer that. So if I add r over and subtract the 0.85, I'm going to get r equals 0.15. And that means that there's an annual decrease and it's 15%. I converted the decimal here to a percentage. For part C, we want to estimate the value when the car will be $8,000. And remember, we're in thousands of dollars. So that means my Y value is just going to equal 8. And we're going to use our calculator here. So we're going to do this in class tomorrow. So you can leave that blank and we'll finish that in class tomorrow. Then I want you to take a look at example 3, because this one is representing exponential growth. So we looked at decay, and now we're going to look at growth, which you want to use a parentheses 1 plus r to the t. So reading through this problem, I want to write an exponential growth model, and I know that my a is, let's see, 6.09 billion. So my a is 6.09. Okay. Then my R is an increase by 1.18%. So my R, move that decimal over, is 0.0118 because I'm moving this decimal over 2 times. Okay. And then what else do I need here? I need T, my time. It's going from 2000, because that's when everything starts, to 2005. So my T is just 5 years. And then I want to plug them into this equation over here. So Y equals 6.09 times, what is that, 1 plus 0.0118 to the 5th power. When you calculate that out, you should get approximately 6.46, and this is billion people, because remember, we're calculating the population in world population in 2005, so in 5 years, based on this problem. We're going to do part B in class tomorrow along with the monitoring progress.